Hi everyone, welcome to BTech Guru. This session is going to be on an important topic, time, speed and distance. See, this with regarding to any bank examination, time, speed and distance is a very important topic. Right. So, we will first discuss the concepts. So, these three parameters are interrelated. So, we'll have a origin, we'll have a destination, d is the distance between them and t is the time taken. Right. So, speed is equal to distance by time, so it is equal to d by t. So, this is the very basic formula that we will be using throughout this topic, right. So, speed is equal to distance by time, and we have the units. This is very important, because if you are very careful about the units, we can avoid a lot of mistakes. So, the most commonly used unit is kilometer per hour. So, how many kilometers you travel in each hour. So, that is the speed, right. So, that is kilometer per hour, and the another unit is meter per second, right. So, these two, they are the commonly used units at time, speed and distance. So, it is kilometer per hour and meter per second. In most of the problems, you will be in need to convert one unit to the other and vice versa. Okay. What is the conversion factor? Let us see. How many meters are there in a kilometer? It is 1000. And how many seconds are there in an hour? It is 3600. Right. So, if you cancel, it comes to 5 by 18. So, if you are converting kilometer per hour to meter per second, by what factor you have to multiply? It is into 5 by 18. Right. If they gave it in meters and seconds and the choices are in kilometer per hour, you have to take the reciprocal. That is, you have to multiply it by 18 by 5. Right. So, kilometer per hour to meter per second, the conversion factor is into 5 by 18. Right. If it is meter per second to kilometer per hour, the conversion factor is into 18 by 5. See, the thing you have to be very keen in time, speed and distance is the units, because most of the mistakes that people do, they are in the units. The data given in the question, they will be in a certain unit, and the answers, they will be in an entirely different unit. So, if you are careful about the unit part, will be very it will be very easy to arrive at the final answer. Okay. For example, the common type time, speed and distance problem, you will be given two journey data. Two different journey data, right. Of them, among time, speed and distance, two of them will differ and one will be constant. For example, in the morning, you are going from your home to office in your bike, right. In return, you find that your bike has got a problem and you come back by bus. In the journey, the time will differ, the time you take to go to the office by bike and you come back with the bus, that will differ. The speed of the bike and speed of the bus will differ, yes, but what will remain constant? The distance will remain constant. Likewise, in the two journeys, right, either time will be constant. If you find that the time taken for the journey is constant, what you have to do is you have to equate the time parameters. So, if speed is equal to distance by time, what is time is equal to distance by speed, and distance is equal to speed into time. If you find that the distance is constant, what you have to do is equate the distance parameters. So for equating distance, you will be given the speed, two different speeds and two different time. So one side speed into time is equal to another speed into time. You have to choose variables accordingly to arrive at the final answer. In certain cases, very rare cases, you may find the speed as the constant parameter. So speed is equal to distance by time. So one distance by time is equal to another distance by that time taken. So that will give us the final answer. The thing is, you have to find it out which one is the constant in the given question. So when we are discussing problems, we will look problems over this. So are we clear so far? So speed is equal to distance by time, time is equal to distance by speed, and distance is equal to speed into time. Right? We have two different units. Right? One is kilometer per hour and meter per second. Right? Between kilometer per hour and meter per second, the conversion factor is into 5 by 18. Between meter per second and kilometer per hour, if you want to convert it, the conversion factor is into 18 by 5. So that is it. Now we are going to see one more concept called as the average speed. See, if the distance travelled in a whole journey, it varies by parts and the time taken varies. For example, from one point to another point, you are using different modes of transport. Say you travel by bus and you travel by a cab, etc. For the same journey, the average speed will be different. Right? Like numbers, the average is not sum divided by number of numbers. So for numbers sake, this will be the average, sum of the given numbers divided by the total number of numbers, but you won't be using this in average speed. Average speed is an entirely different concept, right? That I will explain what it is. This is a speed parameter, right? So we have a numerator and a denominator. When it is speed, the numerator has to be a distance parameter. It is total distance. The denominator has to be a time parameter. It is total time. So average speed is nothing but total distance divided by total time. Right? For example, this is your origin and this is your destination till this point, right? Say the distance is u, you are traveling at x kilometer per hour, and say this distance v, you are traveling at y kilometer per hour. What will be the average speed? Now we will substitute. The total distance is u plus v divided by, is there any time given? No, time is not given directly, but you can calculate time. We know that time is equal to distance divided by speed. So for this journey, the time taken is distance divided by speed. For the other part of the journey, it is distance divided by speed. So this is how we will calculate the average speed. Right? In certain cases, they will give you the time. Right? Speed and distance they will give, or speed and time they will give, or time and distance they will give, and we have to substitute it accordingly. If you don't have distance or time directly, you can calculate it with the other two variables. It is not necessary that the data should be given directly. The data it may be given in other form, and you may have to derive the necessary data in most of the cases. Right. Is this clear? Right. So, in average speed, there is a very specific case called onward and return journey. Right. You start at a particular point, right? You do a journey, you reach here, and you come back to the same place. There is one onward journey and one return journey. Right. But if the speeds are different, for example, you travel at 40 km and here you travel at 60 km while coming back, what will be the average speed? See, it is not 40 plus 60 by 250 km per hour. The average speed is different. Right. How we will calculate the average speed? We will have variables because we need to derive the formula. Right. The distance between the 2 points is d. Between your origin and destination, the distance between the 2 points is d. The onward journey speed is x kilometer per hour and the return journey speed is y kilometer per hour. Now, we will use the same formula, total distance. So, you go to the destination and come back, but at different speeds. Right. What is the total distance traveled? In onward, it is d, and in return journey, it is another d. So, it is d plus d divided by, we have only distance and speed parameters, no time is given. The onward journey time taken is distance by speed plus distance divided by speed. We will simplify 2d divided by, the LCM is xy dx plus dy. Right. You take it to the numerator, right. 2dxy divided by d into x plus y. So, you cancel the d terms and you got a average speed formula as 2xy divided by x plus y. The advantage of this formula is you don't need to know the distance, you don't need to know the time. What we have here, all the variables here, they are just speeds. So, if you know the onward journey speed and return journey speed, you can calculate the average speed. You don't need to worry about what is the distance between the points and what is the time taken for the each journey. If you just know the onward journey velocity and return journey velocity, right, you can calculate the average speed of the journey. Right. Okay. So, this is a very, very important subdivision in average speed. This is a very specific case of average speed. So, you go at x kilometer per hour and come back at y kilometer per hour. Total distance is d plus d. Time taken for onward journey is d by x. Time taken for return journey is d by y. Right. So, 2d x plus 2d divided by dx plus dy divided by xy. If you simplify this, you get 2xy divided by x plus y. Right. So, this term, it has only velocities. So, if we calculate for the numbers 60 and 40, the onward journey speed is 60 and the return journey speed is 40, we will find out what is going to be the average speed. As I already told you, the answer is not 50, 60 plus 40 by 2, 50, it is not so. The average speed is 2 into 60 into 40 divided by 2xy divided by x plus y. So, 6 4s are 24, 24 into 2, 48. So, it is 4800 divided by 100. The answer is 48 kmph, right? So it is not the numerical average, it is the average speed 48 kilometer per hour. So this is how we will be doing it. Okay, we will move to the next concept, the most important concept in time, speed and distance. It's called as the relative speed. So what is relative speed? See, till now we have been discussing about only one moving object. What if there are two moving objects? Time, speed and distance, the whole topic, it speaks about two moving objects that are moving in straight lines. So you have two possibilities. One is same direction. If two objects or two moving objects moving in the same direction, and two moving objects moving in opposite direction. Okay. Now we will find out what is the relative speed if two objects move in same direction, and what is the relative speed if two objects move in opposite direction. Okay. We have all experienced what is relative speed in our day-to-day life. I will give you a scenario. Imagine you are traveling in a bus that is moving at 60 kilometer per hour. You are going on a highway, the bus is moving at 60 kilometer per hour. Another bus, it starts overtaking you and its speed is 70 kilometer per hour. Now, if you look at the overtaking bus, it appears, it is not true, it appears that the other bus is moving slower, right? When two objects move in same direction, when you look at from your moving bus, the other bus seems to go at a slower speed, right? It appears, that is why the word relative is there, right? It is not the true one, it appears to be, right? So in this case, it appears at a slower speed. So relative speed for the same direction, it is the difference between speeds. What is the difference between 60 and 70? It is 10 kmph. See, I will give you a comparison. The same situation is similar to you are standing still and the other bus is crossing you at 10 kilometer per hour. These two scenarios, they are one and the same. What scenario? You are moving in a bus that is moving at 60 kmph and there is another bus overtaking you at 70 kmph. That scenario is similar to you are standing still and a bus, it crosses you at 10 kmph. Both of them, they will take the same time, right? That is what you have to understand. Both the scenarios, they will take the same amount of time. Okay. We have a question. What if two objects are going and coming with the same distance, and then what will be the average speed? So we have this question. See, that is what we have discussed specifically in this a special case of average problem, where between 2 points, the onward journey distance and the return journey distances, they are one and the same, right? Onward it is d and return it is d, right? So the total distance is d plus d. See, the speed will only vary in this specific case, the distance will not change. If the distance changes, we will be using the first formula you have seen, total distance divided by total time. This one is a very specific case of average speed, right? Clear? Okay. So we will come back to our relative speed, right? So we have same direction it is difference between speeds. So I gave you two scenarios that are one and the same, 60 and 70, and you are standing still and the bus is crossing you at 10 km per hour. Both will take the same amount of time. Right. Now, the other scenario is two buses moving in opposite direction. Say your bus is moving in one lane, you will take the same speeds. Right. Your bus is moving in one lane in 60 km per hour. Another bus, it is coming in the opposite lane, I mean in a different lane at 70 km per hour. Most of us, we don't realize that a bus crossed us. Right. It appears that the bus is traveling at a relatively higher speed. It will cross us within a fraction of a time. Right. So that is what. So the speed appears higher. Right. So relative speed in opposite direction is the sum of the speeds. Right. We have to very clearly remember, don't confuse it. In same direction, it is the difference between speeds. In opposite direction, it is the sum of the speeds. Right. Same direction, difference, opposite direction, sum of the speeds. Right. So this is called as relative speed. This scenario is similar to you are standing still and a bus is crossing you at 130 km per hour. Both of this will take the same amount of time. So for clear understanding, this is how you can remember relative speed. See, these two scenarios, they are one and the same. They are not different. The time taken for these two and these two, they will be one and the same. Right. So this is relative speed. Okay. Where and all we will apply relative speed. That is very, very important. We now know what is relative speed. Now we have to understand where and all we will apply relative speed. If the problem has certain keywords like time to meet, time to catch, right? Like when the two moving objects will meet, when the two moving objects will catch. These type of keywords, you have to definitely find the relative speed. Right. Now we have a time parameter. So what and all should come in the numerator and denominator? Time is equal to distance divided by speed. The denominator is the speed term. Right. The speed is nothing but relative speed. Whenever we have two moving objects, mostly we will be using the relative speed. Right. Whenever it comes to two moving objects, we will be using the relative speed. Please remember that. In the numerator, there should be a distance parameter. Right. What does the distance parameter means? Initial distance. What is initial distance? That is very, very important. Say two places, they are 300 kilometers apart. So the distance is 300 kilometers. Right. At 9 o'clock, a bus starts from, we call them as A and B. At 9 o'clock, a bus starts from A that travels at 50 km per hour. The speed of the bus that is starting from A is 50 km per hour. It is starting at 9 o'clock. Here at 10 o'clock, a bus starts at the speed of 60 km per hour. Right. Okay. The thing is, if you have this, right, the question will be like, at what time they both will meet. But to find that, we need to know what does that term initial distance mean. I will tell you. At 9 o'clock, only one bus is moving. But at 10 o'clock, only at 10 o'clock, both the buses are moving. Initial distance is the distance between the two moving objects when both of them are moving. Right? It is the distance between the two moving objects when both of them are moving. So only at 10 o'clock, both of them start to move. Right? So we have to subtract the distance that is covered by this bus in 1 hour. Right? So the bus speed is 50 kmph. So in 1 hour it would have crossed 50 km. So the total distance is 300 minus, we have to subtract the distance covered by the first bus in 1 hour. Right? This is going to be the initial distance. The distance between two moving objects when both of them are in movement. Here at 9 o'clock only one bus is in movement. Only at 10 o'clock both the buses are in movement. So we have to subtract this distance divided by when both of them are traveling in opposite direction, the relative speed will be 50 plus 60. The speed will be 50 plus 60. So it is 250 divided by 110. Right. 25 by 11, it is 3 by 11 hours. So after 3 by 11 hours, again, is it from 9 o'clock or 10 o'clock? We have that question. It is only from 10 o'clock. So roughly it will be 12 3 by 11 o'clock. It is not hours, it is 11 o'clock. At this time, they both will meet somewhere in between. Right, okay. We have a query. Right. So is there any shortcut method for average speed without using the formula? Unfortunately, there is no shortcut. To be frank, what I have taught you is the shortcut. Right. You have to be very careful with the units, and most of the time the numbers will be simple and you can easily cancel it. Right. So this is the shortcut. Right. So we have two cases in average speed. The second one, what I taught you, is the special case. So between 2 points, onward journey and return journey. Right. The first one, you have to find the total distance and divide it by total time. Okay. So this type of questions are mostly asked. In this case, both of them, they traveled in the opposite direction. Right. Now, how will you calculate when both of them are in the same direction? Imagine there is a thief. Right. He took your purse and he started walking. You realize that you lost your purse only after he crossed 100 meters, or he is now 100 meters away from you. You are shouting and you start running. That guy is also running. Say the thief runs at 4 km per hour and you are running at 5 km per hour. When will you catch the thief? Right. So what is the distance in between? It is 100 meters. Remember carefully, this is in meters, but the speeds, they are in kilometers per hour. What you have to do is convert this 100 meter into kilometer. It is 0.1 meter. Right. Now, time to catch. So chasing scene. Right. Time to catch is equal to initial distance. If both of them are traveling in the same direction, what is the relative speed? It is a difference divided by 1 kmph, 0.1 hour divided by 1 kmph. It is 0.1 kilometer. So it is 0.1 hours. If you convert it into minutes, you have to multiply it by 60. So it is 6 minutes. So you can catch that particular thief in how many minutes? 6 minutes. So this is how we will do the calculation when both of them, they are moving in the same direction. Right. So in relative distance type problems, most of the mistakes they will be done either in units or in the initial distance part. Definitely they will change the initial distance. One of the object will start moving earlier and you have to subtract that particular distance covered from the total distance, right. So I'll again tell you what is initial distance. It is the distance between two moving objects when both of them are at movement. Only from that time we have to calculate the time taken to meet also. So is this clear? So this is the predominant application of relative speed, and we will be using the same relative speed concept in other derivative topics of time, speed and distance also, like trains and in boats and streams we will be using the same relative speed concept, right. And always be very careful about the units, right, because that is very important, and if you do a mistake you'll lose the confidence, and when your confidence level goes down your brain loses the capacity to reason, right. So be careful with the units. Small things will help you to gain a lot of marks. So what we have seen so far, it is the formula between time, speed and distance, right. The unit conversion, the average speed, the special case in average speed, the onward journey and the return journey, and the relative speed concept. So relative speed, in the same direction it is the difference, and in opposite direction it is the sum, right. Are we clear so far? Okay. So now we will look at the questions. So we will look at question number 1. Ram was walking on a road to reach a place that is 1 kilometer long to reach a destination. After he crosses 2/5 of the distance, a dog starts chasing him and he starts running at double the speed, thereby completing the entire stretch of the road in 14 minutes. Now at what speed he runs when the dog chases him? Now you have two journeys. One is him walking and the other is him running while the dog is chasing him, right. What is given? The running speed is twice that of his walking speed, right. So we will take, if x is the walking speed, what will be his running speed? 2x, right. So what is the distance between the 2 points? It is 1 kilometer, right. But after he walks 2/5 of the distance, so 1 into 2/5 kilometer. This is nothing but 0.4 kilometer. 1 into 2/5, it is 0.4 kilometer. And the remaining stretch, obviously it should be 0.6 kilometer, as the total distance is 1 kilometer, right. Now what is the total time taken for him starting the walk? The dog starts chasing him in between and he goes to the other end of the road, right. The total time taken is 14 minutes. Now we have one conclusive data, that is this 14 minutes, but this is in kilometers and the speed we usually take it in kilometers per hour. So to convert this 14 minutes into hours, it is 14 by 60 hours, right. What is this 14 minutes? It is the time taken to walk plus time taken to run, right. The total is 14 minutes. So we take W as walking and R as running. What is the time taken for walking? What is time is equal to distance divided by speed. What is the walking distance? 0.4 divided by x plus 0.6 divided by 2x is equal to 14 divided by 60. What we did, we know that the time data is conclusive, so we are now equating the time part, right. What is the time taken? The walking time plus the running time is equal to 14 minutes. We converted it into hours by dividing it by 60, right. Walking distance divided by walking speed, running distance divided by running speed. Now we will do the simplification part. 0.8 plus 0.6 is equal to 14 divided by 60. 28x is equal to 1.4 into 60. So 0.8 plus 0.6, 1.4. X is equal to 1.4 into 60 divided by 28. We will cancel it by 7. This will come to 0.2 and this will come to 4. If we cancel this and this, it is 0.2 into 15. 2 15s are 30 and 1 decimal point. It is 3 kmph. Remember the units, the speed we took, they both are in kilometer per hour. But the problem doesn't stop here, right? If you look at the question, right, what is the question asked? Now at what speed he runs when the dog chases him? So we have to tell them it is 2x. The problem doesn't stop here, right? So the answer, the final answer is 2 into 3, 6 kmph. Again, you can do the same problem in the other way. Right? So walking time plus running time is equal to 14 minutes. You calculate, you get the walking speed, right? And then you calculate the running speed. You can, the other way is, you can take this as directly x kilometer per hour and this will be x by 2, right? So if the speed is double, if this is x and this is going to be x by 2. Now even if we do it, 0.4 divided by x by 2 plus 0.6 divided by x is equal to the same 14 by 60. So this will give you, if you take this to the numerator, 0.8 by x plus 0.6 by x, which is equal to 14 by 60. 1.4 divided by x is equal to 14 by 60. X is equal to 1.4 into 60 divided by 14. 10 times 6. X is equal to 6 kmph. Now I solved the same problem in two different methods because you have to understand how we have to choose the variables. See, if you are choosing a variable, at the end of solving that variable, you should get the final answer, right? In the first method, we didn't get the final answer in the solving of the variable. We again have to multiply it by 2 and tell them that is the answer. But if we assume what is asked as the direct variable and keep the other one as derived. See, here we fix this as x kilometer per hour. So this became x by 2 and you solve, you will get the same answer, right? But one step is less, right? So you can save time by choosing appropriate variables and choosing which factor as a proper variable, right? So that is what you have to take care of. In course of practice, that will come to you, right? So is the first problem clear? The speed of him running when the dog starts chasing him is 6 kmph. Now we'll look at the second problem. Nathan is standing in a platform while a train crosses him at 5 km per hour and it takes 35 seconds. How much time he will take to cross the same train at 5 km per hour if the train halts on the same platform, right? So now we have two different journeys, right? Nathan is standing in this platform and the train is crossing him at 5 kmph. How much time it takes? 35 seconds, right? Now the same train is standing in the platform, right? The same train is standing in the platform and Nathan is running from the engine to the guard compartment at 5 km per hour. What will be the time taken? See, for this question, actually, you don't need to do any calculation. This is a common sense question. See, if a data is given in the question, it doesn't mean that you have to do a calculation with it. The question is pretty common sense. See, he is standing and the train is moving, right? What is the time taken? 35 seconds. Now, the train is standing and he is running at the same speed. So, the same time will be taken. Yes. So, Nathan will take 35 seconds to cross the train. That is it. See, most of the questions, he will be in need of common sense. Right? This question is not a direct TSD question, it's a common sense question. But definitely, sometimes they will ask questions like this to trick you. Right? You will be doing some calculations with this 5 km ph and 35 seconds, you will be finding out the length of the train and all, but not necessary. Right? Irrespective of whether he stands or the train stands, since the speeds are the same, the time taken is also going to be the same. So, Nathan will take the same 35 seconds to cross the train. Right? Is it clear? Okay. We will look at the third question. A hungry lion spots a deer that is 150 meters away from it. It starts chasing the deer at 36 km per hour, but the deer realizes it a little later and starts running for its life at the same speed. Note that carefully, at the same speed when the distance between it and the lion is 50 meter. When will the lion catch the deer? That is the question. When will the lion catch the deer? Okay. So, the time taken to catch. You have that keyword in the particular question. Right. So, time taken to catch. So, you have initial distance divided by the relative speed. What is the initial distance? You have two distance data. One is 150 meter, another one is 50 meter. Which one you have to use it as an initial distance? It is 50 meter. Right. So, 50 meter, you convert it into kilometers, you divide it by 1000. Right. What is the relative speed? See, they both are running in the same direction because the lion is actually chasing the deer. Right. So, they are moving in the same direction and they both are running in the same speed. So, what will be the relative speed? 0. So, the time taken will be infinity. That means the lion will never get the deer. If at all they gave the speed of the lion is more, right, even it is 1 km per hour, you can calculate when will the lion catch the deer, because there will be something called as a relative speed and you will get a conclusive numerical answer that will tell you when will the lion have a feast on the deer. Right. So, this question is to understand what exactly is the initial distance, because we have two distance data in the question. One is 150 meter, another one is 50 meter. So, which one we have to use it as the initial distance means it is 50 meter, because that is when the deer realizes that the lion is chasing him. Okay. So, the answer is the lion will never get the deer. Okay. We will go to the next question. Without traffic, a bus travels at average speed of 45 km per hour, and including the traffic, the average speed is 40 km per hour. How much time the bus was standing idle? Right. So, we have two different scenarios. See, since the word average speed is there, it doesn't mean that you have to use total distance divided by total time. Right. So, it is again two different journey data. In one journey, including the traffic, the speed is 40 kmph, because you cannot travel fast if there is traffic. This is with traffic. Without traffic, it is 45 km per hour. You can travel at a higher speed. Right. Now they are asking how much time the bus was standing idle. Right. So, how much is the speed difference? It is 5 km per hour. See, 45 km in 1 hour. That is kmph, 45 km in 1 hour. So, for 5 kilometers, how much time will be taken? So this is the time, is actually the idle time of the bus, right? Or 5 is the speed difference divided by what is the speed without traffic? 45 into 60. That is it, right? 5 into 60 divided by 45. Right. So 5 into 60, this is 3 times, this is 4 times. If you cancel it, then it is 20 divided by 3 minutes, or it is 6.66 minutes, or 45 is to 1. This is 1 ratio, and 5 is to how much time? 45 kmph in 1 hour and 5 minutes in how many hours? Right. So 45x is equal to 5. X is equal to 5 by 45 hours. So again 1 hour, 5 by 45 into 60 is equal to the same 20 by 6, and you will get the same answer. You can do it in 2 ways, either by forming a ratio, and another one is the difference in speed divided by speed without traffic into 60. That will give us directly the answer in minutes. Or this one, 45 minutes is covered in 1 hour. So how much time will it take to cover this? 5 km. Right, since the speed difference is 5 km per hour. So if you calculate the time, it again comes to 20 by 6, that is 6.66. Just a minute. 20 divided by 3 it is. Sorry, 20 divided by 3. The same 20 divided by 3 will come. The answer is the same, 6.66. Right. So is this clear? So the question will be just 2 lines and gives us a shortcut: change in speed divided by usually the higher speed into 60. That will give us the final answer directly in minutes. Right. We can take this as a shortcut. Right. So is this clear? Okay. We will look at the next problem. This one is an interesting problem. Dwelling in the top of a mountain, a person has to come downhill for supplies to buy his things. It takes him 1 hour to go and come back uphill. The total journey time is 1 hour. His uphill speed taken is only half of the downhill speed. That is obvious, because when he comes down, his speed will be more, and when he goes back, his speed will be less. What is his time taken ratio between downhill and uphill? Right. This you can calculate based on how to say, the traditional method or the common sense method. The traditional method is, what is the total time taken? 1 hour. Right. You have uphill and downhill. Uphill, the time taken, the ratio is, the uphill speed ratio is right, because his uphill speed is only half of the downhill speed. Right. Say if we have the speed ratio as 20 and 40, right, or even 1 kmph and 2 kmph, right, assuming the distance is 1 kilometer per hour, right, the from uphill to downhill the distance is 1 kilometer per hour, the time is 1 hour. So we have to equate the time parameters. So what is time is equal to distance divided by speed. Distance divided by speed plus distance divided by (20 minutes). No. Wait. Yeah, this is enough. Okay. Speed is inversely proportional to time. This thing is more than enough. Speed is inversely proportional to time. If you travel at a higher speed, you will reach the point at a very short period of time. If you travel at a slower speed, it will take a longer time. So, always speed ratio is reciprocal of time taken ratio. We don't need to do a lot of calculations, you can do it like this. The speed ratio is 1:2. Then what will be the time taken ratio? 2:1. Simple. So that means in total 1 hour, the downhill speed, if you split 1 hour into 3 parts, this will be 40 minutes and this will be 20 minutes. So amounting totally to 1 hour. So the speed ratio is 1 kmph and 2 kmph. So it is 40 minutes and 20 minutes. Okay. So this thing you have to remember, the speed ratio is the reciprocal of time taken ratio. The speed ratio is 1:2, so time taken ratio is 2:1. They are not asking you how much time they are taking. The question is about the ratio, right? So the ratio is just the reciprocal, right? So we will look at the next question. Yeah, this is an example of the first type problems when we saw the concepts. Okay. Due to stopping in signals, I lost 1/10 of my speed and reached the office 10 minutes late. What is my normal traveling speed? Or what is my it is actually what is my normal traveling time, because you cannot calculate speed. The thing is, you have again two data, normal and changed. The normal speed is S and the time taken is T. If 1/10 of the speed is lost, it is S minus S by 10, which is equal to 9S divided by 10. Okay, so he is traveling at a lesser speed. So how much time is taking extra? T plus 10. Now in the two journeys, what is constant? Is the speed, time, or the distance? The speed changed, the time changed, and the distance remains constant. So this distance, S into T, right, which is equal to 9S by 10 into T plus 10. Right. So we can cancel S. T is equal to 9T by 10. Look at the question. How much time he takes extra? Right, for this question, how much time he takes extra? It is 10 minutes. So plus 9. So T minus 9T by 10 is equal to 9. So if you multiply this, we will have only 9. So T by 10 is equal to 9. T is equal to 90. What is the unit? Is it hour or minutes? It is minutes. Because since we took the 10 as minutes, this should also be minutes. So it is 90 minutes. So sometimes they will ask you, what is the time taken in the changed speed? So it is 90 plus 10, 100 minutes. Right. So this is the thing. So you have two journey data, you have to find out which one is constant, right? The speed or the distance or the time. So now we find that the distance is the constant, distance is equal to speed into time, and distance is equal to speed into time. So you equate it, you find t is equal to 90 minutes. Okay. So we have a question. A dog takes 4 leaps for every 5 leaps of a hare, but 3 leaps of a dog are equal to 4 leaps of the hare. So compare their speed. Try it out. Now we have the dog and the hare, right? So the dog takes 4 leaps, but the hare only takes 3 leaps. But 3 leaps of the hare are equal to 4 leaps, 3 leaps of the dog are equal to 4 leaps of the hare. For example, in 1 leap, the dog covers 4 feet, right? So 3 leaps of it is equal to 12 feet. Right. For the hare, 4 leaps is equal to 12 feet. Right. Now, the dog takes 4 leaps. So what is the distance it travels? 3 leaps is 12 feet. So 4 leaps is 16 feet. Right. The hare, how much leap it takes? 3 leaps. So its 1 leap is equal to 3 feet. So 3 leaps is equal to 9 feet. This is the distance. Speed is equal to distance by time. So speed is directly proportional to the distance, right? They both are doing it in the same time, so time remains constant, right? So you can take the same distance ratio as the speed ratio. So the question is compare their speed. So if it is the speed ratio between dog and hare, it is 16:9. So 16:9 is the speed comparison ratio between the dog and the hare. See, instead of taking variables, if you assume numbers like this, right? So what is the LCM between 3 and 4? It is 12. So if you have a common such number, you can calculate the distance, right? And it will be very easy for us to compare the speed, because we'll be having numbers and it will be very easy for us to cancel it, right? So is it clear? Okay. Okay, so we'll look at the uphill and downhill problem. I'll explain it again. We have that query. See, a person, he lives in top of a hill. He comes back and goes down. Total time taken 1 hour. The speed in coming back is twice that of his speed in going back. See, speed and time, if the distance is constant, see the distance they travel uphill and downhill, they are constant, right? So when the distance is constant, the speed and time, they are inversely proportional, right? Speed and time, they are inversely proportional. So what is given is between downhill and uphill. See, when it comes to ratios, you have to be very, very careful in this thing, whether it is downhill to uphill or uphill to downhill, because the value will change and the answer will also change. So as per the question, it is downhill to uphill. So his downhill speed is twice that of his uphill speed. That is obvious, right? So when you come down from a mountain, your speed will be higher, and when you go up, your speed will be low. So it is 2:1. Since they are reciprocals, you just take the reciprocal, and this will be the time taken ratio between downhill and uphill. Downhill, he comes in 20 minutes. Since the total time taken is 1 hour, if you split it as 2:1 ratio, downhill will come in 20 minutes and uphill will go in 40 minutes. So is it clear? Okay. So we'll have a very quick recap of what we have seen in 1 hour. So we'll look again at question number 6. Yeah, I told you it is what is the normal traveling time. I think I told you the question is not normal traveling speed, because speed will obviously get cancelled, right? So we can calculate what is the normal traveling time. That alone we can calculate it. Okay. So what we saw is time, speed and distance, right? The unit conversion, average speed, right? A special case in average speed, that is onward and return journey, right? Then it is relative speed, and the time taken to catch and time taken to meet. What is initial distance? The initial distance is very, very important, and please pay attention in the question whether they both start at the same time or they start at the different time. If they start at different time, please subtract the distance. A dog, we'll have a look at the dog and hare problem again and again. I think I got the data wrong. I got it as 4 and 3. Okay. A dog takes 4 leaps for every 5 leaps of a hare, but 3 leaps of a dog is equal to 4 leaps of the hare. We'll take the same example. Say the dog in 1 leap, it covers 4 feet. So in 3 leaps it will cover 12 feet. Right. Now the hare in 4 leaps, it covers the same distance because they said it is equal. Right. So in 1 leap it will cover 3 feet. Now how many leaps that the dog and hare take? This is 4. In 1 leap it is 4 feet. So it is 4 into 4, 16. Right. In the hare, right, it takes 5 leaps. So 5 into 3, 15. So the distance ratio is 16 into 15. Speed is directly proportional to distance. So the answer is 16 is to 15. We can use the same distance ratio as the speed ratio. Right. So now we got it. I got the data wrong. Last time I think I put 3 here. Right. So if it is 3 leaps, the answer is 16 is to 9. If it is 5, with the same logic, the logic doesn't differ. The method is right. I think I got the data wrong. So it is 16 is to 15. Following me? Okay. See, if you use numbers instead of variables, it will be very easy for you to calculate. See, in variables we are prone to make mistakes. If it is numbers like this, right, if you calculate just with numbers, it will be very easy for us also. Right. Okay. And that's for the day. Thanks for watching Beta Guru.